Welcome to Brain Vision.
In this problem, let's see here, 38. We're going to redo 37, and assuming that everything is isentropic, which actually makes things a lot easier, but it'll allow us to kind of compare the efficiencies. So again, we have 10 megapascals up here, 1 megapascal here, 10 kilopascals here, same power output. Same temperatures here, 500 degrees C, but now our isentropic efficiencies are 100%. So let's see here. T3 and P3 can give us H3 and S3, which is also S4 now. And we have S4 and T4, which can give us H4. We have, this should be 5 again. T5. So T5 is 500 degrees Celsius. So we have T5 and we have P5. So we get H5 here and S5. And the entropy at 5 is the same as the entropy at 6. So we have at 6, then we have the pressure and the entropy. So we can get the quality factor. It winds up being about 95%. And the entropy at 6 is 2,461 kilojoules per kilogram. Saturated liquid at 1 at 10 kilopascals. So we have the enthalpy and the specific volume. Again, we can get the work from the turbine into the pump. And again, we can see it's slightly less because we have a perfectly efficient pump. So we can get the enthalpy at 2 then, is this plus this. And now we have the enthalpy everywhere. So we can look at the boiler. And get the heat transfer into the boiler from here in these pieces to be about 3,870 kilojoules per kilogram. The work out of the turbine is this minus this, the enthalpy here minus the enthalpy here, plus the enthalpy here minus the enthalpy here. So that winds up being 1,610 kilojoules per kilogram. So we subtract off the power into the pump, get the net work to be about 1,600 kilojoules per kilogram. And so we can compare those. Again, we can see we have more work out of the turbine, quite a bit, and we have quite a bit more net work out because we have ideal everything. And so the efficiency now goes up to 41.3% instead of 34.1%. And our mass flow rate goes down to 50 kilograms per second instead of 63 kilograms per second. And so we need less flow because we have the same net power, we have the same power output, but we have a more efficient system, so our specific work is higher. So we're going to wind up with need less flow to get 80 megawatts.